In the previous video, we learned about some reactions in which you can convert one group on a benzene ring into another group on a benzene ring. And prior to that, we learned 5 ways that you can introduce groups onto a benzene ring. Given those 8 reactions, it gives us lots of latitude in terms of doing syntheses involving installing groups on benzene rings and converting them. That plus the ortho-para-directing and the meta-directing power of various groups allows us to do lots of different kinds of syntheses, but requires that we be very careful about when we introduce various groups and when we convert them into other groups. I thought what we would do here would be simply do a few examples of synthesis on benzene rings, and that will illustrations that and some of the strategies that we use when we do these sorts of syntheses. So the first one I would like to attempt is para-nitro benzoic acid. So I would like you to stop the video for a moment and see if you can think of a way of preparing that compound starting with benzene itself. Welcome back. Let's think about this. The problem is both of these are meta-directors, so how do you get them to go in para to each other, and how can you start with benzene itself? Well, clearly we have to make one of those groups initially from an ortho-para director, because obviously they are para to each other. The best way to do that would be to start with an alkyl group on that position, toluene, or some other alkyl benzene. And if we then nitrate it, since an alkyl group is an ortho-para director, then we simply have to convert the alkyl group into a carboxylic acid group, and that's our old friend Jones, or KMNO4, to oxidize the alkyl group to a carboxylic acid group. Note we're converting an ortho-para director into a meta-director, so even though both of these are meta-directors, we can stick the original group on para due to the fact that this is an ortho-para director. Now there's a bit of a bookkeeping matter we have to deal with here, and that is, if the directions to the synthesis say you have to start with benzene, then we would have to put this group on to a benzene ring itself. Typically the directions for a synthesis problem will be to prepare a particular compound from benzene or toluene. And the reason for that is toluene is readily available, and so if you need an alkyl group on a benzene ring, you can go ahead and start with toluene. So if the directions that said start with benzene or toluene, that our group would be an alpha group and you'd be done with the synthesis. If the directions that said we need to start with benzene itself, then we would have to install that R group. Let's think about how we might do that. If we had to start with benzene itself, can you put an R group directly onto a benzene ring? And the answer is yes, theoretically. We have to use the Friedel-Crafts alkylation, but you remember there are problems with that, particularly the over-alkylation difficulty, so it's hard to stick one R group onto a benzene ring. So how could we get around that problem? Well, what we would do would be to initially do a Friedel-Crafts acylation with perhaps some R group on a C double bond O with a chlorine and aluminum chloride. That would give us the acyl benzene, or a phenylketone, if you will, and then we use the Wolff-Kishner or the Clemmensen reduction to turn that into an alkyl group without the C double bond O. Then we do the nitration and the oxidation, and we get the product that we want. Let's do another synthesis. Let's see how we might prepare meta-chloro butyl benzene. So we want to make a benzene ring with a chlorine and a butyl group meta to each other. Well, here we have sort of the opposite problem we had in the previous synthesis. Both the chlorine and an alkyl group are ortho-para directing, so how can we put them on meta to each other? Again, we have to start with one or the other of those groups being something that is initially a meta-director and then convert it into the group that we end up with. How would we do that? We would start with Friedel-Crafts acylation. So we start with benzene itself, do an acyl and aluminum chloride, put the acyl group onto the benzene ring. That's a meta-director, so that will then chlorinate with chlorine and FeCl3 in the meta position. And then if we do the Wolff-Kishner or the Clemmensen reduction, let's use N2H4 and concentrated sodium hydroxide. That would give us the product that we want. If, on the other hand, we wanted these two groups to be on para to each other, we would start with chlorination. In fact, let's do that synthesis. We want to prepare para, chloro, and butyl benzene. How might we do that? Well, it seems to me the best way would be to start with chlorination. So start with benzene, chlorinate it. Again, we'd use Cl2 and FeCl3. Since that's an ortho-para director, we can then, that would give us para, and then do the Clemmensen or the Wolff-Kishner, and that would reduce the acyl group to an alkyl group. Okay. Or in this case, you could do the acylation, reduce it, and then do the chlorination. Either way would work fine because both this group and this group are ortho-para directors. And let's look at a third or fourth possibility here. What if we wanted to prepare a benzene ring with an amino group, in other words, aniline, with a C double bond O CH3 group in the meta position? How might we do that? Well, I'm going to suggest that we start with benzene. We put on the acyl group first, then we nitrate, nitric acid and sulfuric acid, and then we reduce it with iron and HCl. And putting on the nitro group, since this is a meta director, we're going in that position, and then reducing the nitro group to an NH2 with iron and HCl would give us the product we want. Now you might ask, could we, instead of acylating first and then nitrating, could we nitrate first and then acylate, and would that give us the same product that we could then reduce with iron and HCl? And the answer is, that's not going to work. Why not? Well, remember, Friedel-Crafts reactions don't work on deactivated rings, so if we nitrated it first and then tried to do the Friedel-Crafts acylation, it wouldn't work because nitrobenzene is a deactivated ring, and Friedel-Crafts reactions, either alkylation or acylation, do not work on deactivated rings. That'll finish it for this episode. Thank you.